Cliff is currently hanging the microphone from a piece of string from the ceiling.
Not string, twine.
Twine, because he wants to be able to use his hands.
Come on. And Brady, meanwhile, thinks that he can sort of capture me on a microphone that is...
That's a bit low, isn't it?
It's a bit low.
It depends.
Crank it up a little higher than
Depends where you're sitting. I'm Brady Harron, and the guest on today's Numberphile podcast, if we ever get it set up, is Cliff Stoll. Now, people who watch Numberphile videos might recognise Cliff as this guy.
If you think math is about numbers, you probably think that Shakespeare is all about words.
You know, the Klein Bottle Guy.
What I'm interested in is a little section of topology called non-orientable manifolds. More specifically, I'm interested in Klein Bottles.
The man with thousands of mathematical glass sculptures stored in the crawl space under his house in Oakland.
Under my house is my little forklift robot.
And you might even remember seeing this. He retrieves them with a remarkable homemade remote-controlled forklift. Complete with a little camera on the front so he can see where he's going. But as you're about to learn, there's more to Cliff than the wild-haired, super enthusiastic guy you've seen on YouTube. It's a story of KGB-funded computer hackers, a long-lost schoolteacher, and some predictions about the future of the internet, which ended up being, well, maybe a little bit embarrassing. But let's start at the beginning.
Okay, I'm born in 1950. Apply your retro rockets inside your brain to somebody who's educated in Buffalo, New York, which is a pretty gritty steel city on the east coast of the United States, and with two sisters, two brothers, and folks who are at best making minimum wage. Blue-collar neighborhood, you don't have a lot. My dad worked at a hotel as a bartender. My mom, bless her heart, used the GI Bill to go to college. Her idea was if she could become an English teacher in the public schools, man, that's a job. Little did she know what it meant, but eventually she did. Along the way, the two of them fired 5 shots into the impending baby boom, and 2 of my older sisters are up and away. My 2 younger brothers are out and about, and the world is probably a better place for the bunch of us.
Were you brainy? Like, were you clever at school? Would I have said, oh, he's going to be an astronomer or a mathematician or an engineer one day, that guy?
I wish somebody had said that. Boy, I wish somebody had said, oh yeah, he's the brainy one in the neighborhood. Rather, I felt, here's my chance, going to school to figure out and learn about what's going on around me. The first 5, 6, 7 years of education was strictly public school, elementary school, grammar school, public school number 61. And I got a blue star for good attendance.
Right.
I mean, wow, that is good stuff. And then I started in 7th grade at Millard Fillmore Junior High School. I mean, there can't be 2 schools in North America named after Millard Fillmore.
Who was Millard Fillmore?
Who was Millard Fillmore? Millard Fillmore was a dough-faced president around 1850,
Yeah.
whose claim to fame was that he brought a bathtub to the White House.
Okay.
In fact, he wasn't the first to bring a bathtub there, but that's the main thing that he's known for today.
Is he the most forgettable president then, is he? Or?
He's a very forgettable mediocrity.
All right.
And every now and then in Western New York, there are bathtub races where people put wheels on bathtub to just do Millard Fillmore races. But beside the point. Anyway, so I'm in 7th grade at this cool new junior high school. And it's 1964. Our math teacher is going to teach the new math. Now, the new math is not like that old boring arithmetic and pre-algebra that kids are learning. No, the new math is all about sets, set theory and combinations. And my folks have never heard of it. I'd never heard of it. I'm sitting in and my teacher, Miss Voran, starts talking about what is a set and what are certain rules, the commutative law, the associative law, the distributive law, and what happens when you have a Venn diagram and you make circles and these things. And I'm sitting there, 7th, 8th grade, saying, boy, this stuff is squeaky obvious.
Do you mean you were finding it too easy? Or?
Oh, yeah, it was way easy.
Yeah.
It was just way easy. And this is going on through 8th grade, and Miss Foran is teaching us bit by bit by bit. I'm having a great time because I'm learning really new, novel stuff that I've never thought about. And one spring day, sitting in English class, and English teacher says, you know, some Greek philosopher has pointed out that there's no rule so general, so universal, that it does not admit to at least one exception. So I'm sitting there in English class, and 20 minutes later find myself in Miss Foran's math class, and she's talking about the commutative law. You know, 8 times B equals B times A. Up goes my hand. Miss Foran, Mr. Lama down the hallway. He said there's no universal except. And she says, you're right. The commutative law has an exception. And I'm thinking, oh, this is cool. And she says, it's hard to describe what it is, but I'm going to assume that you're asking a real question, namely, what's the exception to the commutative law of algebra? And so she begins by saying, a matrix looks like this, and draws a matrix of 2x3 matrix on the chalkboard. She says, right now, this matrix doesn't look like it's useful, but I can make another matrix next to it, and I can multiply the two together. Matrix A times matrix B, and I can get matrix C. She points out just how you do matrix manipulation, how you do matrix multiplication. And she says, not telling you this for any test at all, telling you this because you asked a good question. 3 times 7 is the same as 7 times 3 by the commutative law. Matrix A times matrix B does not equal matrix B times matrix A. The commutative law doesn't apply. And I'm sitting there listening, and this stuff is just soaking into me. I'm sponging it all up. And I'm thinking, where would you use a matrix? What is it? What's it for? Bless her heart, she continues. She describes places where you'd use it. You know, you could measure temperatures on different days and multiply them by something. And so I stash it in the back of my mind. Continue on, junior high school, get to high school. Sure enough, at the end of high school, taking a calculus class, and teacher starts talking about linear algebra and mentions, in blah, 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 matrix, blah, blah, blah. I hear this ping in the back of my mind. This neuron fires. It says, oh, I've heard of these matrices before. They don't commute. And I raise my hand and say, oh, they don't commute, do they? And my high school math teacher says, wow, you know about this, don't you? And I said, no, not really. I just know. And I remember how they multiply. So get to college. Up comes linear algebra again. Up comes these matrices all over the place in physics. I get to grad school, and boy, they're all over the place in physics. And every time I see one of these matrices, I remember this day in 8th grade where Miss Foran introduced this absolutely weird and wonderful concept to me. So I'm finishing up in grad school, and my dissertation is, of all things, to define the scattering matrix for the cloud particles in Jupiter's upper atmosphere. In other words, when sunlight falls on Jupiter, the clouds in Jupiter's atmosphere scatter the light in different directions. What direction does it preferentially scatter into? And if I can understand, suppose a lot of the light gets forward scattered, I might be able to say something about how big and what shape are the particles in the clouds of Jupiter. I might be able to say, is it a ammonia crystal? Is it a methane crystal? Can I separate the two by looking at the scattering matrix? And these matrices are all over the place. And I'm fooling with this matrix. And I keep thinking, thank you, Miss Foran. Thank you to my 8th grade math teacher who went out on a limb and spent all of 15 minutes of class time to introduce me, this little pipsqueak in the front row, to matrix algebra. So it finished this. And I think to myself, I need to thank her. I want to go back and say thanks to this woman. So I go back, try to look her up. Miss Foran, where are you? She's in no phone book. She's not listed any place in Buffalo. Eventually, 10, 15, 20 years later, a new century comes about. Matrices, they're no longer this cool new thing that shows up in physics. They're my old friends. They're friends that are helping me figure things out. I can't look at an Excel spreadsheet without thinking about matrices. And I'm thinking to myself, I owe this woman a deep thank you for going way beyond the call of duty.
Cliff, did you find her?
In 2014, I said, okay, I've actually put in some time looking for Miss Foran. I'm going to find out where she is, put my spade into the dirt, going through county paper records. Finally, early 2015, it's now, 50 years since I took this class? Yeah, 50 years since I last saw her. I find, I think there is a condominium in Florida that has her married name attached to it. I called the condominium manager who says, oh yeah, that was sold. Blah, 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 blah. You might want to call so-and-so in Minnesota. So I start calling everybody with this particular last name in Minnesota. 13, 14 phone calls later, I call up this guy and say, I'm looking for Miss Foran. The guy says, huh? You ought to talk to my wife. 30 seconds later, this very, very familiar voice gets on the phone and says, hello? And I say, I'm looking for Miss Foran, who used to live in Buffalo and taught mathematics. And I hear over the phone, yes, this is she. I say, you don't remember me. You don't have any idea who I am. My name is Cliff Stoll. 50-some years ago, you taught me the new math. More than that, you taught me the commutative law. And deeper than that, you showed me what a matrix was. And she says, oh my God, I have followed your career across the decades. I saw you chase down this computer hacker. I read your books. I always wondered whether you were the same kid that was in my 8th grade math class. I wondered if you were the same clever, interesting kid that I taught so long ago. But I never knew how to reach you. And I mail a Klein bottle to her because of all people, she'll appreciate a Klein bottle. Back comes a letter. Back comes a letter postmarked Lake City, Minnesota.
You've got it there.
And it says, Dear Cliff, this letterhead, Buffalo Academy of the Sacred Heart, is where I went to high school.
What does she say in the letter? Like, what's the gist of it?
At the very end, thanks again for looking me up and giving life one more interesting twist. I'm really enjoying it. Take care. Signed Mary, her first name, in parentheses, Miss Foran. I know, of course, she hasn't used that name in 52, 53 years. And in this letter, she says, I now have credibility with my grandkids because they can see you on YouTube. You did a TED Talk. You wrote these books. And they're impressed with me because I was your 8th grade math teacher. What's cool about it isn't, oh yeah, I learned about matrices. No, everyone in math and science and physics and chemistry and biology knows them. My feeling deep inside is that I have a responsibility, and I'd sort of like to extrapolate and say we have responsibilities in general to pass along our appreciation to those people who have done good things for us. Suppose for a minute that you're in 7th grade in Buffalo, New York, at Fillmore Junior High School over on Oppenheimer Street. Okay, hypothetically further, suppose that you're in a science class taught by Miss Cohn, who's teaching. And meanwhile, you have a curiosity about the sky and you say, I'm going to make a telescope. And your folks don't have any money. You don't have any money. So you have to make your own telescope, which means grinding a mirror and polishing the mirror yourself and mounting it in a tube and figuring out how you bend pipes so that you can point it at the sky. And one day I say, hey, I'm looking at the sky with this homemade telescope. And I look at this object and I say, wow, there's a couple stars right next to it. I wonder if that's the planet Jupiter with the Galilean moons around it. And I'm, 13, 14 years old. I have this homemade, not very good telescope. Next morning, I run into school, go up to my 7th grade teacher, and Miss Cohn, I made a telescope. And she says, oh, that's interesting. Put your homework over here and sit down third row. And I say, no, you don't understand. I made a telescope and I was looking at the sky last night. I'm looking at things. And she says, very nice, very nice. Put your homework here and sit down. Class about to begin. I think I saw the planet Jupiter. It had stars next to it. Very nice, young Clifford. Please hand in your homework and sit down over in row number 3 in your chair now. I walked over to sit down, thinking this probably is the way life is. And I go home and mention it to my mom. And my mom says, that doesn't sound right. Let's see if we can find somebody who might know something more about astronomy. She sure didn't. The whole idea of science in my neighborhood was, it was a class you had to get through. So we went over to the Buffalo Museum of Science. I go up to the 3rd floor. There's a door that has gold letters on it. Curator of Astronomy. Knock on the door. Voice comes out, says, come on in. And by now I'm completely, after what happened in my 7th grade science class, what to do. So I say, excuse me, sir, I'm thinking about how I got shut down in my science class in 7th grade.
Were you doing the talking, Cliff, or was your mum doing it? Or were you?
No, my mom just said, you walk in there, you go and tell them what you did. And she's not going to do it for me.
Yep.
So I walk in and explain to this guy who's sitting there smoking a cigarette. And I say, I made a telescope. And this guy looks up and says, oh, really? What kind? A reflector, refractor? What, to make it lenses? I said, no, it uses a mirror. And he says, you ground it yourself? I said, yeah, carborundum grit. And I polished it using this stuff. And he said, what'd you mount it on? I said, well, I don't have much. So I used some cardboard and a couple pieces of wood and a tube and pipes, some plumbing pipes to make sort of a mount.
So this was like a homemade telescope. You hadn't bought a kit.
Oh, no, this is not a kit. This is homebrew. No, it's homemade.
Okay.
You have to go back to 1962, 63 when money was scarce. My family is living off my father's minimum wage job.
Yeah.
There's 5 kids. When somebody would tip the bartender heavy, we would have hamburger the next day. When nobody was tipping, well, the next day it would be beans and rice for us. That's my life.
This astronomer must have been so impressed by this kid that
This guy says, oh, well, what have you observed? And I reach in my pocket and pull out little spiral pocket notebooks. And I say, well, here's what I saw the other day. Open up and show him that, it looks like a bright star with some little stars next to it. He says, I wonder if it's the planet Jupiter. And I'm thinking, I hope so. And so he reaches up on the shelf, pulls off this thick, gigundo book called an ephemeris. It has all sorts of numbers in it and a graph showing where the moons of Jupiter are. He matches my cruddy notes with his wonderful book. He says, oh, yeah, over here. You saw the planet Jupiter. Here's Io. That's the one that you got over close here. Ganymede's over here. Callisto. Yep, it must have happened on Tuesday night at about 7:30. And he looks up and says, this is good work. What's your name? I say, it's Cliff. And he says, what's your last name? Cliff Stoll. He says, okay, from now on, he reaches over to the shelf, pulls out a notebook. He says, from now on, every time you make an observation, I want to see that name in ink at the top of every page. Here's your notebook. You'll notice it's not spiral bound, it's not 3-ring bound. It's a sewn-in notebook. Every observation you make at the top of the page, I want your name, where you are, and the date. Don't forget the year. And this will be your logbook. And by the way, next Thursday, it's public night. Come on up. I'll show you the sky through a real 8-inch refractor telescope.
What did that make you feel?
Oh, it made me feel wonderful, as if somebody actually valued what I'd done. What you've done is interesting. It matches observations that have been predicted in this American ephemeris. He's not saying, oh, hand your homework in and sit over there and pay attention and fold your hands and be quiet. He's actually treating me as if my time is worth something. Well, I showed up for public night, and halfway through, he invites me to tell people about the moons of Jupiter, of which I don't even know their names. And the public night after that, I do my homework in advance, and I'm able to talk about Jupiter a little bit more. And a year goes by. I start taking classes in astronomy at the museum. A couple more years go by, and this guy says, "Oh, I'm thinking of starting a summer program in astronomy." Summer program in astronomy is 5 or 6 high school kids from around Western New York, a couple of whom have made their own telescope, several of whom, hey, they're just interested in astronomy. We're up every day using a solar telescope, figuring out how sunspots evolve. And this guy is telling me, hey, there's this journal that comes in called the Astrophysical Journal. Read a couple articles in it. I open this book. It's filled, just cram-filled with snake-like mathematics that I can't understand. And I say, go up to him and say, I can't understand it. He says, find the ones you can. Read those. And by the way, read this book on how sunspots come about. It's called Brayenloff Head, Sunspots. Start reading it, pretty easy. And he says, pretty soon it starts talking about physics, magnetism, electricity, and dynamos. And boy, it's hard going. He says, read this book over here by Secchi, great Jesuit astronomer, about what's happening in the sun. Read that one. That's 100 years old. That's real easy to read. And I'm picking up all of this. By the end of the summer, whole crew of us head over to a place in Michigan, near Pontiac, Michigan, McMath Hulbert Solar Observatory. We meet real solar astronomers. They're showing us their spectroheliographs and hydrogen alpha filters. And I know what they're talking about. I'm not afraid of a spectroheliograph. Hey, I use a little spectroheliograph at the museum. I understand what a solar flare is. I sort of can see why prominences have the shape there. And I'm 16, 17 years old, and I'm realizing I can actually understand what real astronomers are talking about. They're not talking down to me. When they talk to each other, I can pick up some of the words they're saying and understand just what kind of projections they're doing. And Brady, it was like every now and then I'd bump into somebody whose idea of a kid was not, oh, kid, go over there in the 3rd row. Sit down, fold your hands, be quiet. I'm about to start class. Every now and then I'd meet somebody who gave a damn that I could learn, who cared that I could become somebody much more than who I was now. And over there on the wall,
There's a picture of him.
there's a picture of Ernst Both. I knew him for 48 years. Not a month went by for 48 years that we didn't write a letter, didn't call each other. Along the way, I've realized, oh yeah, he has a master's degree, no PhD. The depth that he knew astronomy wasn't that deep. He was really a mycologist. He was an expert at studying mushrooms because in World War II, when he was 13 years old, he was starving and his folks were driven across Eastern Europe. They had nothing to live on but mushrooms.
So your astronomy mentor was a mushroom expert.
Yes. And he's a flock of mushrooms named after him because he was such a good researcher. The important thing was he understood what research meant.
Why was he the curator of astronomy if he was a mushroom expert? That was just the job that was going.
Like many other people, he was overqualified for this job, but it wasn't open. So he said, yeah, I can do astronomy. And my first book that I wrote, Cuckoos Egg, I dedicated to him simply because he was the one guy who cared, who wasn't interested just teaching. He cared that I grew into a real human.
Looking back now with the hindsight, the wisdom of being an adult who tries to mentor young people yourself, what do you think he saw in that boy who came into his room? What did he see that made him say, I'm going to give this young lad more of my time?
Wow. Surely he saw a guy who was curious, who wanted to fool around. I hope he saw someone who didn't give a damn about, oh, I need a job or I want a letter of recommendation. I hope he saw somebody who was embarrassed that his mom had taken him there. It's a difficult challenge to find the thing that resonates in a kid and feed it enough energy at just the right frequency so it keeps on vibrating and vibrates louder and louder inside of you.
How did becoming a professional astronomer, now you're working as an astronomer, having done all your studies, how did that compare to what you imagined it would be when you were like a kid looking at Galilean moons? Like, was the reality of being a working astronomer more amazing, less amazing, disappointing, surpass expectations? What was it like?
How I wish that the joy of going out in your backyard and seeing a lunar eclipse. Moon gets dark, and the excitement of looking forward to, I'm going to travel to see a solar eclipse someday. How I wish that were reflected in graduate school. How I wish that were well reflected in professional astronomy. It saddened me to finish grad school and start doing postdocs and realizing that, what people want me to do is to write 3 papers a year and get published at least one paper that's good enough that it'll show up on, be reviewed in the annual reviews of blah, blah, blah. What a letdown that so much of what preparation for astronomy led into was writing grant proposals, reviewing telescope proposals from others, figuring out, how do we get funding for this, that, and the other. I found it so sad. Something that was once so new, so true, so hypnotically addictive, is looking at the sky and looking for the Messier numbers, looking for double stars, trying to see if I could resolve divisions in Saturn's rings, and then finding that, having done this, it's now time to write grant proposals. Okay, so as I was doing a postdoc in Baltimore, Space Telescope Institute, and there's 3 or 4 of us walking down the street in Baltimore, and of course, central Baltimore, the sky's pretty bright, and we're walking along. I look up and say, see Venus over there. Astronomer? No kidding. PhD astronomer looks at me and says, how do you know that's Venus? Oh, come on. He says, no, really. How do you know that's Venus over there? I said, look, we're an hour or so after sunset. We're walking west. It's a bright star in the west. Come on, you're kidding me, aren't you? When I realized that there are astronomers who don't look at the sky. The thing that was such a joy to me, lying on my back, looking at the sky, looking for meteors, and going over near a bog, swatting mosquitoes, listening to frogs, looking at the sky and dreaming and imagining. There are people for whom that's not a part of their life. I beeped for Professor Elizabeth Romer. It's my first year in grad school at the Lunar and Planetary Labs, Department of Planetary Sciences at University of Arizona. And there's this phenomenal professor, Elizabeth Romer, who's famous for doing astrometry, precision measuring of star positions, but especially comet and asteroid positions. Turns out to be really important because a lot of comets and asteroids are so faint that you can see them once. If you don't keep following them, you'll lose them. Well, this is 1974, September, October of 74, and I'm taking a class with her. I'm taking a class under the world's most important astrometrist and comet specialist. There's only 2 or 3 other people in the class. A month or so in, she says, I'm going observing up on Mount Bigelow. Anybody want to come along? It's a 1.6 meter telescope. This is a big telescope, and I have a chance to go observing with her. Well, I immediately raise my hand. I say, sure. And 2 or 3 people in the class look at me like I'm a Martian. You want to go observing? So Friday night, go up in the hill, go to Mount Bigelow, about just outside of Tucson. It's cold up there. It's up 1,000 or so meters, and it's hot in Tucson, but it's cold up there. I dress warm and get there. It turns out that in order to figure out the position of an asteroid, you have to let the light from the asteroid fall on a glass plate. But the asteroid's moving, and it might be like a 19th, 20th magnitude object, which is so dim that you can't even see it. So how do you take a picture of a really dim asteroid? Well, you have to let all the light fall on one point on the photographic plate. But the asteroid's moving, so while the telescope is following the stars, you have to carefully move the glass plate, the film, to follow the asteroid. Okay, so the frame of reference is the motion of the stars, and have to slowly offset a glass 10 by 10 inch plate to follow the motion of the asteroid. Ahead of time, you've spent a week doing linear algebra to figure out just how much you turn it. So Professor Romer is there behind the telescope, brings out this hypersensitized nitrogen-baked plate, mounts it in the telescope, opens the shutter, and she will, for the next 8 hours, very carefully offset guide this telescope with crosshairs following a dim star and very carefully manipulating the telescope so the star is exactly on the crosshair. Meanwhile, every 43 seconds, she has to turn a knob on the side of the plate holder that turns a lead screw that causes the plate to move a fraction of a millimeter to follow the motion of the asteroid. Yep, Brady, my job was every 43 seconds to say beep.
What, you had a stopwatch and you were just saying beep every 43 seconds?
I was watching the sweep second hand of a clock in the observatory every 43 seconds from 8:30 at night until 5 o'clock in the morning. Every 43 seconds. Beep. That was my introduction to professional astronomy.
Do you tell that story to make me think, oh, the drudgery? Or was that a thrill for you because you were helping this celebrity astronomer?
Imagine how you would feel if you'd come all this way and you meet this person who's essentially your hero, and you spend a full night counting off 43-second intervals. I mean, a Kodak darkroom timer could do a better job than I was. I mean, it was 1974, but I could have built an electronic gizmo to turn this damned knob a half turn every 43 seconds. I didn't need an Arduino to do that. This is a simple RC circuit could do it. I'm realizing that, wait a second, it's the surgeon having a medical student here doing the scut work just so that you realize, oh yeah, you've got a long way to come, kid. It wasn't 6 months later that a radio station calls up the Lunar and Planetary Lab and says, we hear that there's a meteor shower that's going to happen tomorrow night. What should we do? And nobody's around, so I answer and say, oh, the best thing to do is go out in the desert, bring a sleeping bag, pillow, bring your sweetheart, lay on the back, watch the sky, and look for meteors. Next morning, Professor Elizabeth Romer is threatening to kick me out of grad school for speaking to the public, something that only a professor should do. Again, a real introduction to professional astronomy. And it harkened back to, put your homework over here, sit in the third row, fold your hands and pay attention. Yeah, there's a lot of that in the world.
Now, in 1986, something happened that would change Cliff's life. And it was the start of something which would actually change the way everyone used the internet. At this point, working at the Lawrence Berkeley National Lab, Cliff's supervisor asked him to investigate a minor accounting error, just 9 seconds of computer time that hadn't been paid for. And turns out this was the key to finding a hacker. But this was really before the days when anyone knew anything about hacking. Computer security it wasn't really a thing. Cliff launched his own investigation. He set traps. He monitored the mysterious intruder, eventually tracking him down to West Germany. It turns out this guy was stealing and selling American military secrets to the KGB. Cliff's adventures brought him into contact with people at the FBI, CIA, NSA, but even these people didn't really always appreciate what a big deal it was. But eventually Cliff won the day. The hacker was arrested and put on trial. And when the story broke, Cliff was famous. He's still kind of famous for this, and he wrote a best-selling book about the whole caper. It's called The Cuckoos Egg.
Who wants to be a celebrity? Not me, certainly not you. I don't give a damn about celebrity. I do care about getting the word out. I don't want to be known as, oh, you're the guy that caught... But I do care that people realize, oh, we have insecure computers. I do care that this new thing called the ARPANET, the internet, allows computers not only to link with one another, but allow security holes in one computer to cause problems for someone else. It's not, oh, wow, you're a celebrity, you're famous. No. That's not what I want. That's one of the few things that I learned in grad school was if something happens, write it down. If you don't write it down, it might as well not have happened. But beyond that, publish what you've learned. If you don't tell people about it, it'll happen again, but it'll happen to somebody else in a worse way or better way. So I felt Yeah, caught this hacker. I had no idea that there were such things as computer security problems. There were no books on computer security. And I figured, well, I'll write a scientific paper about it. Wrote a refereed article in the communications of the ACM, what is it? The Association for Computer Machinery, called Stalking the Wily Hacker. A friend of mine, Rich Muller up at Lawrence Berkeley Labs, Rich says to me, Cliff, you ought to write a book. I say, I don't know how to write a book. I don't know how to write. I wouldn't know what to do. And he says, it's real easy to write a book. What you do is you write an outline. For every chapter in your book, make a paragraph. Then write a complete one full chapter. Not the first one, not the last one. Some middle chapter. Write that. Write a biography of yourself. Then mail it to this guy in New York, John Brockman. He's a book agent. So I just caught this computer hacker. It's 1987 or so.
It hadn't been in the newspapers yet or
Hadn't
anything.
been in the newspapers. You know, the FBI kept calling me up saying, don't say anything. The NSA said, oh, don't say anything. The CIA said, don't say anything. My boss says, don't say anything. So I'm good at keeping my mouth shut, except around you, Brady.
Yeah, of
And
course.
so I start writing this book proposal, and I figure I want to write a book called Fundamentals of Computer Security in a Networked Environment.
Right, not catchy, but all right.
Then chapter 1, what's a computer? What's a register stack? What's a disk drive? What's Boolean logic? Chapter 2, what's a program? What's a compiler? What's an operating system? Chapter 3, what's a network? What's the internet protocol? What's the ARPANET? Chapter 4, what's security? What's coding? What's cryptography? One-way trapdoor functions. So I write this outline, 20, 30 chapters, and send to this guy, John Brockman. He's a book agent. 3 days later, get a phone call. No kidding. Looking for Cliff Stoll. This is Cliff. Brockman here. Got your book proposal. Can't sell it. You don't know how to write. And he hangs up.
Right.
And I say, well, perfectly fine. I go back to doing astronomy and physics at Lawrence Berkeley Labs. And a week, a month, 2, 3 months goes by, and somebody in Germany, well, all this stuff's been kept hush-hush secret. Somebody in Germany leaks the story to somebody who leaks the story to the New York Times. One Monday morning, it's Monday morning, and front page of the New York Times, above the fold, Berkeley astronomer cracks computer spy ring.
Had they not spoken to you? Did you not know that was coming? Had they
No.
not interviewed you?
My logbook had been leaked in Germany. Front page of the New York Times, above the fold. It's 4 o'clock over here in Berkeley. My phone rings. Oh, I'm looking for Cliff. This is Cliff. Brockman here. Let me sell your book. Let me sell your book. Huh? Let me sell your book. You're famous. You're hot. Front page New York Times. Berkeley astronomer. Huh? Yeah, let me sell your book. Let me sell your book proposal. John, I can't write any better today than I could 3 months ago. I don't care. You're hot today.
Tell me you didn't give him the deal. You didn't give him
I
the
say,
book deal.
Yeah, go ahead. Just leave me alone. Let me go back to sleep. 8 hours later, this guy calls back. He sold this book proposal that 3 months ago he wouldn't blink an eye at. He sells it for $40,000. And this is twice my salary.
But you didn't write the book in that dry method that you just outlined a moment ago,
I
did you?
sure did.
Did you?
I got out the outline. He calls back 8 hours later. Sold your book, $40,000.
But Cuckoos Egg, the book is not is a bit
So
more got a bit more narrative to it, doesn't it? It's a bit more exciting than this is
So-
what a computer is.
So I start writing chapter 1. What's hardware? What's a register stack? Chapter 2, disk drives and all this stuff, and get through 4 or 5 chapters. A friend of mine, Guy Consolmagno, comes by. We've known each other since grad school. We're in the lunar planetary labs together. We've known each other for 10, 15, 20 years. He comes by, he's joining the Jesuits. Brilliant astronomer, wonderful friend. And so, so I say, well, I'm going to become a published author. Guy looks at me and says, wow, that's absolutely cool. What are you going to do? How are you going to do it? And I look at him and say, well, like this. He wants to see my manuscript. So I show him the 5 chapters. And he starts paging through it. And he gets through about 4 or 5 chapters. He says, looks up at me, and he says, Cliff, this is terrible. You don't know how to write. And I say, I don't care. They're going to pay me $40,000. They bought this book proposal. And Guy looks at me and says, Doubleday's going to sell 600, maybe 700 copies to every computer jock in the world. I said, perfectly fine by me. Guy says, Doubleday doesn't want to sell 400 or 500. They want to sell 4,000, 5,000 if they can. I said, well, all I can do is write what's in the proposal. And Guy says, no. The problem with your proposal is it's all about computers. And I said, that's the whole thing. I chased down these computer security problems. The guy says, no. It's not about computers. It's about people. I said, no, it's not about people. It's about problems in this software, this Unix system. The guy says, no, it isn't. It's about these hackers. It's about these Stasi agents in East Germany. It's about these fools who are leaning on you in the government. It's about these people at the NSA. It's about these CIA spooks. It's about this FBI agent who won't help you. It's about these people in Berkeley who are skateboarding on Quaaludes. It's about this bunch of people you're living with. It's about a little commune. It's about, Berkeley life. It's about astronomers that you know. It's about you. And I say, no, it isn't. It's about register stacks. It's about disk drives. So Guy and I, we would walk around Berkeley and spend a day, and he says, I can't help you. Go find a book on how to write. So we go over to a bookstore, find a book, how to write. And Guy points to it and says, look, what does it say? In this book by a guy named Bill Stott. Something about right to the point or something like this. And it says, whenever you write a paragraph, use the magic words. Well, what are the magic words? He, she, they, them, us, we, but most importantly, I. Don't let a paragraph or a page get by without talking about people. Goes on and says, what do you do when you can't figure out what to say? You ask a question. And you spend the rest of the page or the rest of the paragraph answering the question. When you come to a stopping point, figure out what's cool, what's interesting, or who's doing what. Well, all that stuff's easy to do because, hey, I'm a physicist. I keep a good notebook. So I just started telling stories about what was happening. Meanwhile, whenever I got tired of it, I'd go back to writing a book about computer security, writing a book about how we caught this hacker and how you did it in Berkeley. And so, thanks to Brother Guy, I finished a book that I would have never guessed it.
How did you like the moments of fame where you're on the road and meeting VIPs and telling your story to big crowds? Like, it must have been a really interesting experience. It must have given you opportunities you would never have had otherwise. No?
No. A guy, a physicist friend, comes up to me and says, fame is a lot like a kiss. You know when it's coming. You just feel the kiss is coming. And while it's happening, boy, it takes your brain away from you and all you can think about is this kiss. But you know yourself that when it's over with, you're going to have to live with yourself. You're going to have to be a person that hopefully has integrity, hopefully has a sense of where they're going and where they've been. And you can't call upon the genie to make this experience happen again. This guy says, be very careful of that. Figure out in advance who you want to be, because these experiences are transformative and it's real easy to get rock star disease. You actually think that you're important because, momentarily, these TV cameras are pointing at me. But in a few months or a year, those TV cameras are going to be pointing at somebody else. Realize that you shouldn't try to extend that. No. Use that, put it behind you, become who you wish to be. Work hard to become more of who you are. And in a phenomenally indirect way, that's given me the license, of all things, to fool around in mathematics, topology, to make Klein bottles. I've done a lot of things. How should I put it? I don't want to give them a standing target. If people are throwing tomatoes at me, I want to make sure they mostly miss. I want to keep exploring the universe around me.
Why Klein Bottles? Why has that become your thing? What is it about them?
Well, it's not my thing. I enjoy mathematics and topology. I'm tickled and delighted to supply math fanatics with one-sided surfaces. I'm not a mathematical researcher. To me, the joy of it is it's a chance to meet smart mathematicians and learn from them. It's a chance for me to go and read books about these things and say, now I sort of understand what homeomorphic really means. Or, no, I got that one wrong. I got to think about what a contractile system around a point is. It's a chance to learn and do something that I haven't done before. And like practically every other field, it's arbitrarily wide, arbitrarily deep and high. There are huge amounts to learn and that I have learned. Why Klein bottles? Years and years, 40, 50 years ago, I tried making a Klein bottle in high school in the chem lab. Broke a lot of glass, cut myself, burnt myself out of trying to bend Pyrex tubing, and said, oh, this doesn't work. And then later on as an undergraduate, made a couple Klein bottles that were more or less, mostly less successful. And 72, 73, actually wrote a silly paper about doing this. And then later on in grad school, asked a bong maker to make a Klein bottle for me. It was an absolute disaster. Guy took my $20 bill, and hadn't occurred to me that bong makers oftentimes were bong users. $20 went up his nose probably. And I made some other Klein bottles of various materials as a postdoc. But then after this thing with the hacker died down, realized, I can fool around and make a few of these.
Are you a businessman? Are you entrepreneurial? Like, you've got so many of them and you sell all these different variations and you've got a really fun website and but it is a little business.
It's fun. It's business in the extent that, money exchanges hands. And Brady, you understand this. Brady, of all people, you understand this, that you're not doing this, for money. You're doing it because it's a gas when a 14-year-old kid starts talking to you about topology and they're smarter than you are and they know more and you're learning from them. Or someone's giving a Klein bottle as a wedding gift to a couple and saying, may your lives intertwine like this, be one-sided to you. It just gives me nice feelings. It's a chance to meet fascinatingly wonderful people, not to mention to do a little bit of artistry in class, a little bit of burning my fingers. And not a week and a half ago, somebody comes over here and what's a Klein bottle? So we spend 15, 20 minutes. I show her a bunch of Klein bottles and ask her what she's doing. And pretty soon she's teaching me about the Cantor set. Well, I knew something about the Cantor set and Cantor dust. And she says, oh, but you don't know about the fat Cantor set. And I hadn't realized there was such a thing. And it's the ingredients of thinking in the middle of the night. You could wake up in the middle of the night, instead of thinking, this thought, that thought, I'd start thinking, oh yeah, what does it mean to have zero measure? What does it mean to have a set that when you add up an infinite number of points, you still have nothing? It's just good stuff like this.
Tell me about being a YouTube star. How do you like doing YouTube videos?
Oh, how do I like doing them? Well, Brady, you're there for all of them.
I am.
It's fun. What I think others are unaware of is not all, but many of the things that you come by and I start talking about. It's a chance for me to learn math. It's a chance for me to make a mistake and have people call me up and say, hey, you got that wrong, Cliff. And I say, oh, I didn't know that part. I did something or other on curvature of pizza. And guy comes over and we're talking. He says, oh yeah, you mostly understand what Gaussian curvature is, but what you don't understand is, and I didn't have it all wrong, but I had a couple things wrong. And wow, it was so neat to have a better understanding. Being a star, that goes nowhere. It's like going back a little bit. The people that I'd like to impress? No, that's the wrong word. The people that I would like to show these YouTube videos to and say, look what you've done, are my teachers. Miss Foran, Ernst Both, Jerry Nelson, the people who have left their fingerprints all over me. For me, the joy of being known online or elsewhere isn't, oh, look at me, but rather, hey, teacher of mine, your work wasn't in vain. One of the seeds that you planted turned into this guy that makes Klein bottles.
Let's jump forward to the mid-1990s now, and Cliff, still famed for catching a hacker, writes another book called Silicon Snake Oil. He's skeptical about the internet. He also writes a short essay on the topic, and that gets published in Newsweek. It's this essay, about 10 years later, which is dredged up by bloggers on the website Boing Boing. They poke fun at Cliff's misguided predictions. Although, I've got to say, another 13 years have since passed, and some of Cliff's other predictions ended up being somewhat prescient. Anyway, I'm not going to read the whole essay now, but I am going to read a few chunks of it. I've included parts that are going to, maybe slightly embarrass Cliff. But in fairness, I've also included some of his predictions, which, when you consider They're nearly 24 years old now. Well, I think some of them are rather insightful. The truth is, no online database will replace your daily newspaper. No CD-ROM can take the place of a competent teacher, and no computer network will change the way government works. Consider today's online world. The Usenet, a worldwide bulletin board, allows anyone to post messages across the nation. Your word gets out, leapfrogging editors and publishers. Every voice can be heard cheaply and instantly. The result? Every voice is heard. The cacophony more closely resembles citizens' band radio, complete with handles, harassment, and anonymous threats. When most everyone shouts, few listen. How about electronic publishing? Try reading a book on disc. At best, it's an unpleasant chore. The myopic glow of a clunky computer replaces the friendly pages of a book, and you can't tote that laptop to the beach. Yet Nicholas Negroponte, director of MIT Media Lab, predicts that we'll soon buy books and newspapers straight over the internet. Sure. What the internet hucksters won't tell you is that the internet is one big ocean of unedited data, without any pretense of completeness. Lacking editors, reviewers, or critics, the internet has become a wasteland of unfiltered data. You won't know what to ignore and what's worth reading. We're told that multimedia will make schoolwork easy and fun. Students will happily learn from animated characters while taught by expertly tailored software. Who needs teachers when you've got computer-aided education? Bah! These expensive toys are difficult to use in classrooms and require extensive teacher training. Then there's cyber business. We're promised instant catalogue shopping. Just point and click for great deals. We'll order airline tickets over the network, make restaurant reservations, and negotiate sales contracts. Stores will become obsolete. So, how come my local mall does more business in an afternoon than the entire internet handles in a month? Even if there were a trustworthy way to send money over the internet, which there isn't, the network is missing a most essential ingredient of capitalism: salespeople. What's missing from this electronic wonderland? Human contact. Discount the fawning techno-burble about virtual communities. Computers and networks isolate us from one another. A network chat line is a limp substitute for meeting friends over coffee.
In the mid-90s, my wife and I had 2 children. I found raising kids to be so much more interesting than anything that was online. Meanwhile, there was an enormous amount of hyperbole about our world will be transformed for the better by the wonders of computers and networks. And I was skeptical, as I am skeptical of lots of things. And I made some pretty stupid, rash statements, many of which were absolutely phenomenally wrong, some of which I'm very sad to say were correct. I'm not disturbed at all by being wrong. I hope I'm wrong often. Probably I'm wrong at this very moment. Nor do I preen myself. Oh, I was right about that. Look, I did that, said that right. No, neither of these mean anything to me. The sadness comes from seeing people who have such phenomenal potential, so much to contribute, spending huge amounts of time playing video games, checking in on social networks, and instead of making wonderful, cool things, instead of developing things and changing the world, instead they find, I can escape from reality into this virtual online or offline world. It's not, I'm against computer games, nor is it that I'm against fooling around with systems. Rather, I really love the idea of people creating new things that will change our world for the better. And how can I say? That's the direction that I want to see. It's not like, I'm upset the world is developed this way or that. No, I'm the most precious thing I have, most precious thing you have, Brady, time, is so easy to waste. It's so easy to spend it on things that don't have meaning or importance. I can't judge for you. You can't judge for somebody else. I can judge in my own life, though. I know when I'm wasting time, and I know when I'm doing something that's interesting to me. might be uninteresting to everybody else. I know when I'm making something new, I'm coming up with an understanding of the Poincare disk and how things work in hyperbolic space. I'm not saying I'm pushing back the boundaries of human endeavor. No, Poincare's work's been around for 120 years. Instead, I'm saying work to become. Spend your time not trying to acquire. Spend your time trying to become someone more than who you've been.
Cliff, anyone who spends time with you or sits in your office like I am now can tell that you're a guy who does a lot of stuff and makes a lot of stuff. I have to know, though, how does Cliff Stoll waste time? What's your vice? What's your time waster?
I haven't written an astronomy paper, a physics paper in a couple decades. I haven't written a mathematics paper, ever. I don't think. My whole life is wasted. I'm not doing anything. I mean, I'm constantly building things, but will they leave a lasting impression? No.
But do you see that as a waste of your time? You don't, surely.
I don't know.
The tiling you've done in your bathroom was surely not a waste of time. It was beautiful.
It's fun.
What's the thing you do and you kick yourself and go, oh, that was a waste of time. I probably shouldn't have watched that TV show.
I probably shouldn't have gone to grad school, huh? Yeah, it would have been a whole lot happier if I hadn't. I'd still be in love with the sky. So we all look back and say, oh, yeah, the 17 craziest things I've done. Who can say every time you open a door, you hear the sound of 1,000 other doors slamming nearby?
When you come to the end, like the end of your time.
Yeah, and there's an epitaph.
What should I call you? Like, would you say...
Don't call me on the cell phone. The batteries will be dead.
But would I say Cliff Stoll was an astronomer? Cliff Stoll was an engineer? Like, I would describe myself as a journalist maybe, or a video creator. What's your description? What do I call you? If someone says, oh, I'm seeing my friend...
My dream in high school was I want to get my ham radio license. Got it.
You got it?
Yeah. WB2PSX and later on K7TA, extra class ticket, the whole thing. Learned Morse code to the point where I could send and receive 20 words a minute. Got my radio license, was licensed to work at a FM radio. What am I talking about? FM means fine music, and consistently fine music is found at 88.7 on your FM dial. WBFO, the student voice of the State University of New York at Buffalo. Number one now, number one then, January 15th, 1802. This song was number 11111. Yeah. My dream then was I wanted to do radio. Somehow or another, I ended up doing radio. I was hanging out with the people who started National Public Radio. Then decided, no, I'm not going to go to Washington. I'm going to head over to Tucson, go to grad school. I'm going to become an astronomer. Became one, then became a computer security jock. Became a writer. I wrote a book, then became a topology entrepreneur. Along the way, became a dad, a husband, someone who helped put speed bumps on the streets in Oakland, California.
But above all, ham radio operator.
My wife says, oh, on her gravestone, carve the words, "The jury is still out." I like that. I like her too.
I like that. Let's go with that. Cliff Stoll, the jury is still out. I'll include a few links to bits and pieces, including Cliff's Klein Bottle business, which is a very entertaining website in itself, in the notes that accompany this episode. I'd like to thank the Mathematical Sciences Research Institute for its support of Numberphile. And this episode was made possible by Maya Sound, the audio engineering company based not far from where Cliff is in the Bay Area. Maya Sound aren't here to sell anything, but they're always doing some pretty cool research and projects, and you can go read about them anytime on their website, mayasound.com. Again, I'll include a link. Lastly, and hopefully not least, you can find out more about Numberphile, maybe even support us on Patreon by going to numberphile.com. Thank you so much for listening, and hope to, speak to you all again pretty soon.